to showcase the new capabilities of the Alteryx Predictive Palette. If you are interested in getting more hands-on training, we do offer a couple of machine learning virtual boot camps, which we'll talk about at the end of this session if you are interested in those. So for those of you who are unfamiliar with NewComp Analytics, we are an end-to-end analytics provider that does software licensing, implementation services, strategic consulting, mentoring, and training for all aspects of analytics. So that's everything from analytics strategy to data warehouse development, to cloud architecture, data engineering, to business intelligence development, and data science. As an Alteryx partner, we're really here to support both people who are considering Alteryx as well as existing clients. So if you're using Alteryx on a trial basis, our job is to make sure that you have the support that you need through a guided trial to help solve the use case you want to take on, as well as answer any questions you have about licensing or the tool itself. So after this webinar, if you're on a trial of Alteryx, we're happy to get it extended to 30 days, or if you'd like a trial, we can arrange for that as well. For those of you who currently have Alteryx Designer, but you're interested in trying out the Predictive Palette, we can get a more in-depth demo for you and talk about different trial options around there. So we're here to support you throughout this period of evaluation. With our existing clients, we can also help you with best practices advice, implementation services, staff augmentation, training, and mentoring. We can also help you with office hours. So if you're running into any issues with a workflow, we have some complimentary office hours that you can leverage. So at this point, I'm going to pass it over to Liam from Alteryx.
Hi, Sophie. Thank you very much. Appreciate that. Thanks everyone for joining today. As Sophie said, very happy to spend the time with you, and looking forward to going through this session. So, just to kick things off from the Alteryx perspective, I wanted to share. I'm sure some of you seen in the marketplace our announcement of our new go-to-market strategy around analytics process automation. So I just wanted to kind of provide some background for what that is, and as we go through this session today, if you have this information in the back of your mind, it might help you come up with some ideas of how Alteryx and NewComp will be able to help. So as you can see here with the statistics that are on this slide, data-driven businesses are succeeding. They don't just use traditional BI in their decision making. Instead, they really have built end-to-end scalable analytic business models that automate process and take prescriptive action to deliver fastest business outcomes. And you can see the benefits that they have. The ability to work with more agility, 77% more likely to significantly exceed business goals, 23 times more likely to acquire new customers, and 6 times more likely to retain customers, which is obviously outpacing the competition in the market. And then they're developing more talent in-house and having a higher job satisfaction, which is an incredibly important thing with, as those who are very comfortable with data and analytics, it's a smaller market than we had thought at this time. Now, Kathleen, we can just flip to the next slide there. So, the journey of digital transformation isn't just a single approach. Instead, we should think of it as 3 transformations in one, so data, process, and people. Unfortunately, with most organizations, there's often a lack of real alignment between these 3 areas, and you start to see disconnected silos. So companies with a deep investment in legacy data technology, they always have comparable but less visible costs in the legacy process, and so that are needed to maintain their business models. And this often accompanied with legacy mindsets, as the culture often hasn't adapted to market needs around customer focus or workforce needs around engagement and upskilling to meet the transformation challenges. So when these 3 core assets are not aligned, this tends to be a reason why digital transformation fails. And this is what stands in the way of delivering successful outcomes for a lot of companies that you see in the marketplace. So moving to the next slide, analytics process automation is the alignment of these 3 assets. So first, it means by which we automate the many levels of process in our companies, everything from simple data acquisition and transformation to enriching, analyzing, delivering actionable insights. And by freeing up significant resources who are trapped in these processes, we get to redeploy domain specialists or workers to focus on new, innovative, or high-value work. That's a spark for cultural change to build a digital-ready workforce. And finally, and most importantly, that we believe none of this is possible without transformative thinking about the data itself. So we know that process is hard. One, understanding of the technology doesn't deliver value in the change process alone. It's the data that provides the actionable insights in your high-performing analytics culture. So that's what we believe is most important. And when we group these three things together, that's truly our platform advantage. Being able to align these core components will help with successful digital transformation. And as you go through the session today, if you think about these three core processes and think about how Alteryx can help, that's really where we see our advantage in the marketplace and how we are helping our current customers and those who are looking at leveraging Alteryx in the future. Now I'm going to hand it off to Kathleen to kind of do the deeper dive into the predictive palette.
Perfect. Thanks, Liam. Thanks, Sophie. Hi, everybody. My name's Kathleen Songen. As Sophie mentioned earlier, I work with NewComp, and I'm going to be leading you through a demo of the predictive palette. So we've got a lot of folks here, and I'm sure a lot of interest. So what I wanted to do is just talk a little bit about what is behind predictive analytics, why we would use it, and essentially the path that we would take to set up a predictive model. Then after that, I do want to just do a little tour of Alteryx for those of you on the line who maybe haven't seen it before, just a quick run through. And for those of you who have seen it, hopefully you'll learn something new. So there, feel free to ask questions throughout the chat. However, we may get to them at the end, so maybe it's something that you ask that gets answered along the way, but definitely very much encouraged. So first we want to start off with what is predictive analytics? And we're really talking about data mining here. So a lot of you are here because your company has some data and you want it to predict something or kind of look into the future. And the goal of most data mining projects center around predicting the behavior of future data. So in order to make predictions on future data, there has to be a model that's built on historical data, so it can capture patterns and trends of current data. Now, I have a little image there of a line graph that kind of moves from season to season, and you may be thinking of predictive analytics as just time series. Well, something happened last year, maybe it'll improve or grow or change this year as well. Let's not necessarily be the case. It doesn't always have to be time series modeling, but any type of previous historical data can be used in predictive models. After we create a model on historical data, the goal is then to apply this model to future data where the predicted variable is unknown. So it could be what are sales next year, what are similar types of customers, similar buying habits, any segmentation, grouping, just a whole slew of predictive measures that we'll kind of all touch on. In order to make sure that we have the best predictive model for our company possible, we utilize what's called CRISP-DM, or the Cross-Industry Standard Process for data mining. So if you're familiar with it, you've probably studied it. But this is an open standard process model that describes common approaches by data mining experts. It is the most widely used analytics model, and we're going to talk about all 6 of the phases there. The term data mining in general is tossed around a lot these days. AI, machine learning, data science, all these are kind of buzzwords that are tossed around, but what do they actually mean? When people hear data mining, they automatically think of running advanced statistical algorithms on huge amount of data, but in actuality, data mining is a process that requires a methodology. Those who are beginning their data mining journeys will realize that it takes more than just advanced algorithms to make a project successful. In order to make a project successful, we want to go through all the 6 stages of the CRISP-DM process. The first stage being the business understanding phase, which is the most important phase in CRISP-DM. This is the stage where the business and the data science come to a mutual understanding of the business objectives of a project. I see more often than not, especially in organizations, that business leaders want something done and they go to the data scientists to ask for it, but they're talking in a different language. They don't have the same definitions. So there isn't a business understanding of what needs to be achieved. Of course, any model that doesn't target the desired business object has a low value to a company compared to a model that correctly addresses the business objects and solves the company's high priority problem. This is why the stage is so critical. This is also the stage that determines the business success criteria. So asking the business, what would make this project a success, and agree on a reasonable target. If you want to find out what happens, 50 years in the future, or based on very little information, it is important to kind of understand the attainable goal that you're trying to reach. The second stage is the data understanding, where the initial data is collected and explored. This is where Alteryx really nicely comes into play. It allows you to bring data in from different data sources and explore what you have and try to make insights based on it. In addition, each field needs to be explained, what it represents, and anything like non-obvious hierarchy mapping and any unique project terminology is defined. Again, I go back to speaking the same language and talking about that definition for the KPI. The quality of data is also examined to see if there's any errors, missing values, inconsistencies. And then the decision is made on how to deal with these problems. If there's missing data, do we take it away? Do we replace it, etc.? In addition, the third stage is talking about data preparation. Now, this is where the prep palette in Alteryx will come into play. So ETL, and again, if you haven't seen the tool, I will show it in a second. I just want to show the model first and then kind of talk about how Alteryx can be used to leverage these stages. If the data is not in the correct format, it could take a long time for data scientists to clean it. And depending on how messy the data is, this stage could account for 80% of a data science time during a project. It is always super appreciated when companies have clean data in usable format, but it's not their fault because you may not know what clean or usable data actually looks like. So if you're thinking about jumping in and starting with a model, you do have to take a couple steps back and make sure that your data is clean. Then not until the fourth step does the modeling stage come into play. This is where we actually perform our modeling based on the business objectives. So we've started back at the beginning and understanding the business objectives in order to create the model on that. Then there's an evaluation stage. This is where we evaluate how our model does in terms of accuracy. Companies can do this several different ways, but one way data scientists at NewComp evaluate our models is by building the model on a subset of data. Then we verify the model with an unseen subset of data, and I'll also be showcasing how to do this in Alteryx as well. For example, we generally do a random split of the data set into partitions. So 70% so we could build our model on, and then 30% so we could test our model and then verify on that 30%. If it's not accurate enough, or it doesn't answer the business objectives in question, then we go right back to the first stage. So absolutely no shame in that. If the model is not working, it's not answering your question, you can't force it. So we have to go back and reconsider what that question we want asked is and what the result we want to get from. We make any necessary changes until we're satisfied with the results. The last stage of the model, once we've had our evaluation and it's good to go, is the deployment stage. So we'll make sure that the model is deployed and integrated in our business system. Now, how does Alteryx and the predictive palette play into this? So before I start talking about the predictive palette, like I said, I will just show Alteryx for those of you who haven't seen it. So I first like to start off with the Alteryx community, and everybody has access to the Alteryx community. And this is where you can find information about other use cases that different companies have done. Also, people just post their general questions to this page as well. We have a variety of posts and people who go through and answer questions in order to seek solutions. Folks like myself will go through and kind of type in answers and even sometimes reply with the exact answer with your data set if you provide it. In addition, there's also an academy. So there's just some learning paths that are available as well as certifications that you could take. For example, if you're working with Excel a lot and you want to kind of see what lessons, what you can do in that tool and how it compares to what's going on in Alteryx, you can take a look at the interactive lessons in order to show them. There's even the predictive modeling section, which we'll talk about today. However, this is just a brief introduction into each of those tools. And again, we don't want to go into modeling until we know how to prepare our data and what the proper path is going to be. So definitely recommend you go ahead and check out the community page. Next is Alteryx itself. So I have it open right now on my screen. If you have a different version than me, yours may look a little bit different. So this tool is organized like any other tool. You can save and open files that are associated. You can look at samples and look at tutorials from the help page and take a look at the community as well. In addition, some of the new features for those of you who haven't seen yet, you can also go ahead and change the interface to a different language. So for my Canadian friends on the line who switch between English and French, it is very, very helpful. Then we have these tabs at the top of our screen called palettes, and each of these palettes have tools associated in them based on a common theme. So the in and out palette, for example, has tools on how to input your data and how to output your data. Then we have the preparation palette. This is what I was talking about when I was talking about preparing data. This is where you would go in order to prepare your data in a way that's usable for any predictive modeling. This can mean data cleansing, so making sure you have the right data types and there aren't any nulls or strays values. Also, creating formulas in order to look at the tool or look at the actual number that you want to predict. Same thing with creating samples of your data in order to create a validation and estimation model as well. And we will be using all these tools when we go through a demo of a predictive model today. In addition, you may be joining data from different data sources. This can be leveraged using any of the join tools or maybe even unioning historical information to continuously create a model that looks at information in the future or from new customers. Any messy data coming in, you can also parse that information. And you can also completely transpose, pivot, crosstab your data, or summarize in order to show a group or subgroup of your data. We have other cool tools like connecting directly to your database to do transformations, creating reports, documentation, and even spatial, where you can take a look at your spatial data and see information like distance away or distance in a particular area. What we're going to be focusing on is starting with data investigation and the rest of the predictive palette. The reason I want to start with data investigation, because that was one of our main steps in the CRISP-DM model. We want to make sure that when our data is coming in, then it's working or it's correct, the data type's correct, and we have enough data points available in order to build a predictive model off of. The data investigation palette allows you to do this with a variety of tools. If you ever wonder what a tool does, you can go ahead and click on it and there's a little description associated with it, or you can simply Google it and also there will be a step-by-step guide on how to utilize the tool. For example, let's say I wanted to look at the field summary tool. Here it says it produces a concise summary report of descriptive statistics for the selected data columns. If there's a little hyperlink, that means that I can open up a new tab and it's going to tell me information about the field summary tool and what each of the outputs do. Essentially, what I want to do is that I want to bring in some data, I want to investigate it, then I want to decide how I'm going to clean it up, and then clean it up in order to prepare it for a model. You can even do things like automatically create histograms or scatter plots in order to automatically see if there's any trend in your data and offer some things like Spearman correlations, Pearson correlations, etc. All things that we talk about when we kind of deep dive into learning about the predictive tools. The other palettes that are there vary between predictive, A/B testing, time series, predictive grouping, and prescriptive. The designer includes a suite of predictive tools, and they all use R, an open source code based, used for statistical and predictive analytics. So if anybody on the line is familiar with using R, I have to use it all through my studies and manually code this out all yourself. This is what the tools are based on. The tools cover data exploration, specialized elements of data preparation for predictive analytics, predictive modeling, tools to compare and assess efficiency of different models, and tools to group records and fields in systematic ways, and also tools to help deploying predictive analytic solutions. For example, with a predictive palette, this is used in order to contain both classification and regression models, as well as tools for comparison and things that are relevant to the model. In A/B testing tools, we can look at A/B testing experiments, such as examining the effect of new market communications, communication campaign on sales. Time series, this is looking at data over time, and it allows you to see trends seasonally through years, through months, through quarters, whatever time series palette you want. Predictive grouping allows you to take a number of fields and segment them into groups based on common features. And we also have prescriptive analytics, which includes tools that can assist with determining the best course of action or outcome for a particular situation or set of scenarios. What we're going to focus on is the predictive palette. But before I do that, again, I just wanted to show each of the tools that are located in each. In the predictive palette, I have information like boosted model, cat regression, linear regression, which we'll be using today, neural network, network analysis, etc. All these tools can be used, like I said, in order to do general predictive models for both classification, which is categorical target fields, and regression, which is numerical target fields. As well, it can be used to further break down any traditional statistical models, and a single score tool can be used as well in order to actually display the results. Next, we also have A/B testing. Like I mentioned, A/B testing is used to carry out test and learn experiments, as they're called. And this tool can help determine market areas for a test, usually for the ones that involve mass media advertising, where everyone residing in the area can potentially be exposed to the advertising, and matching one or more control units to each treatment unit. Then we have time series model. So again, contains a number of tools that help with forecasting, such as ARIMA, which is an exponential smoothing forecast model, and can be used to create items such as weekly sales forecasting models. It also has ETS and methods to develop forecasts based on systematic, time-related elements for a particular target field. Also, as you can see with our predictive grouping tools, we have the ability to group based on things like k-means cluster analysis to create things like customer segments, purchasing patterns, and sets for store groups. It takes your information and puts it in a feasible perspective for businesses. And then finally, if you look at the tools under prescriptive, this includes tools that can, again, help determine the best course of outcome. So like I said, I did just want to kind of showcase all of these tools and see what they could do. As you can see, there's a lot of them, and today we're going to be focusing on the predictive palette, and then I'll showcase the new features in the machine learning suite as well. So the use case we're going to cover today is a data set that's used in order to predict winnings for an internet gambling site. We're going to have two use cases, and I want to showcase two different regression techniques. The first use case is to create a model to predict how much a person is expected to win on average. Since we're trying to predict a numeric value, we can use a linear regression in order to do so, or decision tree. In the second one, for looking at logistic regression, we are going to see if the overall winner is positive or negative. So we're going to do a 0 or a 1 and see if our tools can help us predict that as well. Under the predictive palette, like I mentioned, we have a variety of tools all split up into that classification and regression. So either looking at a categorical target or just looking at a numerical. In order for me to set this up, I'm going to go ahead and open Alteryx, and I'm going to bring in some data in order to make it possible. So I'm always going to start at the very left-hand side in my in and out palette and input some data. I'm going to input it into this giant white space called the canvas, and on the left-hand side, I'm going to connect to a file or a database. I have the ability to connect to any saved files such as Alteryx files, Excel, Zip, spatial files, and I could drag and drop file connections into the view as well. I can also connect to data sources like SQL, Amazon, Redshift, Snowflake, anything that your company connects to, or if I have Alteryx server set up, I can connect to data sources that are kept specifically on the gallery. I'm going to select a file, and I'm going to connect to this data set called casino data. That's the information that I have. And it's going to input a file with Excel. So I only have one sheet here, and you may notice this looks a little bit different because with the newer version of Alteryx, you have the ability to select a range, either cells, rows, or columns, when previously you just had to bring in everything. So we're already filtering out data that is unnecessary or that we may not even need to include into our analysis. After I bring this data in, I see a preview on the left-hand side that tells me all my categorical fields. And what I want to do is I want to browse the data in order to automatically check its data quality. I'm going to click Run. And what this is going to do is it's going to show me each field and a breakdown and summary of information for each. So for example, I have things like user ID, country, language, gender, age, the day, stakes, winnings, and bets. If I want to look at a particular data set, for example, if I want to see a breakdown of country, I can click on country and it's going to tell me that 100% of my values are okay, meaning that none of them are null, none of them are empty, or none of them have any punctuation that may not be necessary or fields that maybe I don't need. I have information, alphanumeric information, for example, the longest and shortest word, but also more importantly, I have a breakdown of how often each of the values appear. So for example, I can see that Germany pops up the most. About 52% of my data has information on players from Germany. And also I have these kind of smaller areas at the end for each of my values. For example, Luxembourg only has 2 fields and Sweden only has 6. And this isn't even aggregated data. So we need to make sure already that we're making sure that we have a model that's going to reflect the whole entire database. And I'm telling you right now that if I only have 2 data points from Luxembourg, I'm probably not going to be able to predict what players from Luxembourg win, unless that one individual is representative. So in order to make sure that I have kind of a cleaner set of data, I'm going to go ahead and start cleaning it and condensing information that may give me false results. I want to eliminate any fields that are repeated, and I want to have a unique key for each individual. I also want to do a bigger breakdown of my data. So rather than only seeing it in the Browse tool, I'm going to utilize one of my data investigation tools, and I'm going to use this field summary tool. I'm going to attach casino data to my field summary tool, and I'm going to add browse tools to them. If I add a browse tool onto a variety of different tools, they will show you different things. So for example, if I'm looking at the predictive tools or data investigation tools, it will actually give me a summary of my data in the form of an image. The browse tool will give you that breakdown that I saw previously. And if I'm just looking at any tools with any data set, then it will show me the data. Under the configuration, I have to check all of the fields that I want to do an analysis on. So for example, I'm going to deselect user ID because it's just a unique field, and I'm going to go ahead and run. The results are going to give me a summary of my data in the table below in the results window. I can see the age, the minimum, maximum age, median, standard definition, and how many unique values I have. Under bets, stakes, winnings, again, all those numerical values, I can see some stats about each of them. But things like country, gender, and language, again, these are word values or string characters, as I could see in the metadata. So I don't have any information about the min or max. I can also take a look at the overall results. And for the numerical values, it just gives you a plot of all the fields. But what's most important are the additional values, such as what percent is missing, what's unique, what's the standard deviation. And in addition, I have some things for my string and character fields like country. I said that I don't have any values missing. However, the minimum value count is 2. And I even get some warnings here. So some values of this field have a small number of value counts. If appropriate, consider combining some value levels together. This is already prepping my data for a model because it's saying that I have some fields that are probably not representative of my whole data set. So what I want to do now is I want to take this data and I want to group it. Analyzing it, it looks like I have a lot of repeating user IDs because I have users that play multiple times and it's recorded per date, but I want to see the average win or loss per player. In order to do that, I'm going to condense my data, and to condense my data, I'm going to bring in the summarize tool. The summarize tool allows me to group, sum, average, and do a lot of different transformations on my data. For each user ID, country, language, gender, and age, I'm going to go ahead and group the fields together. And for my stakes, winnings, and bets, I want to take the average. So I'm going to add a calculation, a numerical calculation on the average. After I run that, I want to showcase how my data looks before and after the tool was run. The reason being is, again, if you haven't seen a lot of the tool before, what the tools do is they'll always show you a overview of your data. For example, before I had 5,161 records and 10 fields, and I could see my user IDs repeat. But after, I could see that I only have 530 records because I have 530 unique users and only 8 fields because I didn't include any time information because I'm not doing a time series analysis right now. So I could automatically see the transformation and always keep both of my data sets in check in and out of each of the tools. Next, what I want to do is I want to set the fields that I want to predict. In my case, I want to predict the overall average winnings. So I'm going to go ahead to my preparation palette and I'm going to bring in a formula tool. The formula tool, as you guessed it, is going to allow you to create a formula based on the fields that you have. And the field that I want to create is a new column, and I'm just going to call it overall win. I can either choose from a list of functions that are available in Alteryx, from date time to finance, math, spatial, specialized, world's your oyster. You can also bring in columns, constants, and you could save expressions that you use commonly in your organization. What I want to do is I want to take the average winnings and subtract them by the average stake that a person placed, because I want to see if overall they won or they didn't win. This is going to give me a numeric value, and it's going to give me a data preview of the first row. So for example, somebody won $14 for the first player at least. Next, I want to change this to a numerical value, so I'm just going to go ahead and change it to a double with the data type below. Underneath, I'm going to add a new formula, and I'm going to call this positive win. So this is going to tell me if the user won overall or lost overall. So instead of just doing a specific numerical value, maybe my business objectives change and I just want to see how many people win and how many people lose. And I want to be able to predict if the person is going to win and lose based on this information. I'm going to reference the calculation that I just created above. So I'm going to say if my overall win is greater than 0, then 1, else 0. And I'm going to end that if statement with an end if. I'm going to zoom in here so everybody could see. Again, after the workflow is being run, I can always see the information before or after the formula tool. So before, again, I only have 8 fields, and now I have 10 again because it's also included this overall win and this positive win as well. Now what I want to do is I want to put this in my predictive palette. However, I only have 530 records here, and I want to be able to see if I could guess some of them. In order to guess them, I'm going to do what I mentioned and create an estimation and a validation sample. Now, with this tool, it's really easy to do. All I have to do is bring in my Create Samples tool, and this is going to split my data into streams. An estimation stream, a validation stream as well, and then any additional info. I'm going to do a classic 70-30 split. So 70% of my data is going to be used in order to create the model, and the last 30% is going to be used to see if the model ran correctly. I'm going to set a random seed as 1, so if any of you want to recreate this later, then you should get the same results that I do. After I run this tool, I should see that the amount of data splits up. In my estimation sample, for example, I have 371 records, and in my validation, I have 159. Now I'm ready to put this into my tool. So the reason that I'm not doing a lot more data prep, for example, I have all these red points here because my numbers, the average is kind of messy. There's a lot more decimal places that maybe I'd like. It's just because I want to show you how the results are going to look after I've run the model, and then things that I could do to go back in order to improve it, just to go through the whole process of a CRISP-DM model. So I know I want to predict the winnings, and I know the fields that I have, but now I'm creating the model to see if it's reasonable. In order for me to create this model, I'm going to use the linear regression tool. This allows me to create a relationship between a variable and some other fields. The example they have here is, how does the number of bedrooms and bathrooms in a home impact the value of the home given in the market? So more, you would expect more. In this case, I'm just going to connect the linear regression tool to the estimation sample. And I'm going to rename the model Casino Guess. In the configuration, I have to ask, or it's going to ask me, which target field I want to choose. So in this case, I want to choose the overall win because this is what I want to guess. I want to guess what the person's going to win based on the country they live in, the language they speak, their gender, their age, and the number of bets that they've placed. Notice how I do not automatically put in all the fields. Let's think about this. Why would the user ID affect how much I win? The user ID is just a random set of numbers. In addition, I used winnings and stakes in order to calculate the overall win. So this would give me way too much information and fit a model before I even know how much I win. Theoretically, if you just guess the winnings, you can definitely choose the stake. And my positive win, again, this is based on the overall win, so it's going to obviously be a very good indicator in order to predict my data. I'm going to add browse tools to my interactive output and also my results output. And I'm going to run the model just to show you how the results look like. What this is going to give you is it's going to give you an output with not a lot of stream of information because it's just the model that's been created on the back end. Then what the results are going to show me is they're going to show me each one of the fields I've selected, and they're going to tell me if they were a good indicator or not of creating my model. If I click on the results, I have a little table, and it tells me the intercept and information about each of my countries and how good they were at predicting the model. If I want to see how well they were at predicting the model, then what I want to look at is this p-value. Now, this is more getting into a conversation of statistics, and again, if you grew up learning R, then it would be familiar lingo to you, but essentially we want these values to be as small as possible. So we want values 0.05 and lower, and the more little stars I have, the better indicators they are. So Germany, France, Greece are good indicators in order to predict, and bets, age, etc. In addition, it splits up overall all my fields and tells me what were good indicators. For example, country, language were good, but gender wasn't that good of an indicator. And we can even see that in a breakdown of the data. When we're looking at how many males versus how many females play, I don't have a good representation of the female population. Bets and any residuals as well. So in order to kind of clean this up, I can use another tool, which is the stepwise tool. This is going to do automatically what I just did verbally for you. go through each of the features and let me know which one the best indicator is. In order to determine the best indicator, I'm going to connect my model to the stepwise tool, and I'm going to use that same stream of data, the estimation sample, and it's going to tell me which one of the fields I should drop. I'm going to go ahead and run this again. So as these tools are running, of course, it does run the model from the beginning again. So we can always just use an output of the data after it's been prepared and then run it through the model if you're going to run it multiple times. But like I said, I just wanted to show each tool step by step. The output of the stepwise tool, once again, is going to break up each of these features, but in addition, it gives you a breakdown of these fields, which are different than I had before. It'll take out some fields that I had previously that maybe made my model not as good of an indicator. So see, I have country, language, gender, age, bets, and residual. And in my other one, I have country, language, age, and bets. So gender has been taken out of the study in order to be used as a predictor. Finally, now when I have my model, I want to, you can name this model, it gets automatically named for you. So I'm going to go ahead and bring in the score tool. What the score tool is going to do is it's going to take that model output, connect it with your validation data, and see if it could predict the values properly. One of my inputs allowed me to input the data. So I'm going to input the data from my validation model. So not the original model. And then I'm going to put the output into the model. Finally, I'm going to add a browse tool at the end. I'm going to name my model. I'm going to leave all the defaults as is and go ahead and run it. So as this model is running, like I said, it takes the casino data, takes a look at each of the fields in the field summary tool. I've summarized it to be on a user per user basis. Then I check the overall winnings, the stakes, the guesses, cleaned up any fields that may not be good at predicting the model, and then decided to score them all together. So what we should see is now the results of the prediction. But what I really want to see is why some things still need to be changed. Like I told you, I want to take you through the whole CRISP-DM model. So we're going to see why some of the predictions were really good and how some of them could be improved, again, based on the data preparation stage, which is the most important. We want to see that most of our users are coming in from Germany or Turkey, they're males, and see how that predicts their overall win. So for example, here, my first individual is from Turkey. He's a male, 39. The overall win, he's lost $10, and the prediction was -18. I have another individual from Switzerland, and he won $2, but the prediction was 6, so that's a little off. In addition, we have another Turkish male, and he lost $5, and the prediction was 4.8. So what can be skewing this data? Let's take a look at this record 4. Again, we realize we don't have that many female representation in this data. So it took it out as an indicator. And the prediction thought that she would lose $4, but she actually won. And you could see that throughout the data source, that the female prediction is pretty off, where it keeps predicting they lose, they actually win in some cases, or vice versa. So we need to go back to this company and say, you do not have a good enough representation of females in order to make a predictive model. So instead of just taking that out as one of the indicators, you should filter out those individuals in order to clean up your data. Now you could do 2 different models and 2 different studies. How do females play, how do males play, etc. And also, let's think about our countries. So most individuals are from Germany, so they're pretty good at predicting those German countries. But if I take a look at Italy, for example, I don't have a lot of Italian players. They guessed they'd lose $8, but they actually won $2. So this is how we would take that model, go back to the beginning, and filter out the information we don't need. Now what I'm going to do is I'm just going to place this into a container. I'm going to hide that just because I don't want it to run every single time I run this data flow. And just in order to kind of clean up my data as well, I'm going to name these containers. So this is going to be my field summary, and this is going to be my linear regression. So I can do the same thing with this predictive palette, but now I'm going to look at that logistic regression. So again, I was looking at a positive win or a negative win instead of just looking at a value. So I'm going to look at this as my casino log, or positive, I guess. And this time my target variable is going to be positive win. I'm going to use the same features, country, language, gender, age, in order to guess. Same thing with bets, but this time I just want to see if the win is positive or negative and how that changes my analysis. Now, instead of going through and using each tool step by step, you've already seen how they work. So I'm going to go ahead and bring in the stepwise tool again in order to eliminate any fields that may not be good indicators. And then finally, I'm going to add the score tool and attach my model to the output. These always automatically attach together. My model to the output and my validation model to the data, and also see my results as well before I run the tool. If you don't do things like set the names, for example, outcome or prediction, then it's just going to automatically name it for you. So originally we were looking at a numerical model that was taking a look to see what the actual value of the win was. And now we're taking a look at the model in order to see if they won positive or negative. So I've gone back and I've decided that this would also be a good way in order to judge my data, but keep in mind, I still haven't changed my data. This is for me to show you how important it is to prepare your data and make sure you have a proper selection sample in your data set. If I take a look at the output of my logistic regression, again, looks similar to before, except I have a lot more little asterisks. Also, if I take a look at the interactive palette here, it looks a little bit different. So this time it's just kind of telling me my accuracy, my precision. So how much it's predicting positive and how much it's predicting negative, because it's a different type of model. And in addition, my stepwise function is getting rid of features that probably weren't that good predictors. And finally, my output is going to do my prediction. So for example, for my first win, again, my Turkish male, we guessed well that they were going to guess negative. So 91% prediction that they were going to be negative. So that's 0. But again, when I don't have enough information, I'm not going to get an accurate guess. With my female from Turkey, they guessed 65% that she would lose, but she overall won. So again, if you go back and try to guess a lesser value, this isn't actually going to change the features. Instead, you have to go out and filter out the correct information and determine that we have a really good model based on our players from Turkey and our players from Germany, where we have the most. If I take a look at this country again, I can expect to see a good prediction for Germany, Turkey, France, and I can now decide what I want to do. Do I want to separate per country? Do I want to separate male, female, etc.? Now, that's just a brief intro in how to kind of prepare these tools and how to use the logistic and linear regression. But I also want to showcase some new tools that are available with Alteryx if you don't know how to set these things up or if you're still kind of unsure. So I just wanted to talk a little bit about the Alteryx Intelligence Suite. So machine learning is used to create accurate predictions, inform the best strategies and success every team. And I knew to use a linear regression and a logistic regression, but you may not know what type of model will best fit your data. What the Alteryx Intelligence Suite is going to do is it's going to take the information, it's going to take your data, and it's going to make critical decisions based on those statistics. This suite, assisted modeling, is going to be used in order to select a target field and create an algorithm that matches your data best. It's a 6-step process where it just has you select the target, confirm your data types, clean missing data, select any additional features, choose the algorithm that's right for you, and then also compare the different models to each other. So what I want to do is I want to take the data that I just created, and I'm going to go ahead and I'm going to use the assisted modeling. Now, this is additional. It's downloaded with a new feature. You need an additional license for it. And the machine learning palette includes things like assisted modeling. If I bring in the assisted modeling tool and connect it to my data, let's connect it to my estimation sample, for example. I still need to have an estimation and validation sample to prepare my data. It asks me if I want to use assisted modeling, so if it wants to guide me through creating a model, or if it just wants the expertise in order to create one on its own. Since I want to show everyone the features, I want to show the assisted modeling. Once I click the assisted modeling, it's going to go through each of those steps that I was talking about. Selecting a target field, selecting data types, cleaning up missing data, selecting features and algorithms. The nice thing is that there's a little preview of each step so you know what to expect, especially when you're doing things like cleaning data and selecting features. I'm going to click Start Building, and it's going to ask me to choose an available target. In this case, I want to choose Overall Win. Here, automatically, and I didn't choose regression or anything like that, but it automatically suggests that I do regression because I'm looking at a numerical outcome. It's going to ask me to confirm, and then it's going to ask me to set my data types. So user ID, it's automatically coming in as numeric, but it's asking me to verify because it's not really sure what this data type could be. If I set it to an ID, the feature is automatically dropped because IDs aren't used in our predictive palette, but I still have things like age, country, language, etc., and positive win. Don't worry, I'll remove those later. In addition, asked me to clean up missing values. I don't have any, which is good for me. And also, I could deselect features. So for example, it says that I have a lot of good indicators here because I know Germany is a very good indicator. However, as I've seen in my data, I have really low data points and it's not actually a good one. In addition, I have things like stakes and winnings, which are not good because they're used in order to calculate my calculation. And the tool is really good with this. Sometimes it'll give you a flag and it'll tell you if there's too many highly associated predictors. After you've selected, it asks you between 3 algorithms: a linear regression, a decision tree, and a random forest. So with the tool, you can actually compare all of them together. It's going to build each tool out, and it's going to vote on the one that is best at predicting your model. So right now, my linear regression is 1. It has the lowest root mean squared error, meaning that it's the best at predicting my model. Random forest and decision tree can also be used. I have a glossary of terms on the right-hand side because it's assisted. So if you want to see kind of what the overview is, what the interpretation looks like, and also the configuration that's available. And once you've selected a model that you like, you can add it to your workflow. Now, when I add the model to my workflow, it's going to automatically add all those steps that I did manually with you. It's going to show you what data types were selected, how the data was cleaned, the linear regression, and it also trained the model. You can then take that model, connect it to your predictive values, and add a browse tool at the end in order to automatically set up your prediction. You can do the same thing with the decision tree tool as well. When you connect and look at a positive win, it's also going to ask you if you want to choose a model. Again, using these features, it's predicting my overall win, which is actually closer than I had before. -10 and -13 is a little bit better of an indicator. And if I go to my features, so my mails from Germany, then I could see how the mapping is very, very close. Like I said, I can also set up an assisted model with the machine learning tool for decision tree as well by adding this to my estimation sample, running the model, and just choosing the appropriate step for me. So a lot of really cool things that you could do with this tool, a lot of cool things that you can do in order to set it up, and just try to get insights out of your model. Honestly, trying it is the best bet. And I'm running out of time here, so I'm going to give it back to Sophie now to talk about some additional features. And if you want to do a deep dive into the tool, we also have created a huge course on this, which is NewComp Analytics Machine Learning. We're going to go through the history of Predictive, do a deep dive into each tools, and also go through the machine learning and intelligence suite palette. So I'll bring it back to you, Sophie. I'll just bring up your slides.
Perfect. Thanks, Kathleen. So folks, as we're wrapping up just with a few of our endpoints, feel free to ask any questions in the chat window or in the Q&A, and then we'll be sure to get to those. So in terms of resources going forward, as you mentioned, if you're looking to extend your trial or get set up with a trial or do a deeper dive on the predictive palette, so please feel free to reach out to myself or Liam. We'll be sending out a follow-up note, so you'll be able to easily just reply back to that. As well, with workflow building, we do offer complimentary help for those who are trying out Alteryx or who own Alteryx and need help anything Alteryx related. We offer free office hours, so you're welcome to reach out about that as well. In terms of training, actually, Kathleen, let's go to the next slide. We'll get a little bit more deeper into the training piece. There we go. So these are the two, oh, sorry, one more, Kathleen. We'll go out of order. We'll go crazy today. So these are the two machine learning boot camps that we talked about at the very beginning. So if you are interested in getting deeper into what Kathleen presented on today, these are our two options. They're set up to be done virtually. That's why they're a little unique in layouts. So we have 3 half days or 5 half days. Obviously, the 5 half days, you're getting a little bit deeper into it. And the 5 half days also includes a half day of kind of one-on-one sessions with the instructor to be able to go through your own personal use case with your own data. These can be purchased through Alteryx, through enablement days, or directly through UCOP. So either way, so if you already have a relationship going with your Alteryx reps and have some enablement days you're looking to use, this is a way that they can actually be applied. If you'd like any more information on either of these two options, we do have a more detailed curriculum, which we can share. Kathleen, do you mind going back to the previous slide, which I skipped over? There you go. Thanks. So these are 2 upcoming Alteryx and NewComp webinars that we're going to be running. So the first one is Alteryx for Excel users that Alteryx will be hosting. This is a great session for folks who I don't necessarily want to call it Excel hell. I'll say Excel very proficient and might want to learn about how Alteryx can help automate and improve some of those processes that you might currently be doing in Alteryx. The next one here is Alteryx and grocery retailers. This is one that is really interesting, not just for grocers, but also for brick and mortar retail locations or even CPG manufacturers, folks who might sell their products in grocery stores. We talk about using location analytics for marketing campaigns, which are often a partnership activity with the supplier and the grocer. So this would be another really interesting event. So that's it from our end. Are there any questions that popped up? Liam, did you have any through your chat window? I'm clear on my end.
No, I'm clear on my end as well. I don't see anything. I just want to say thank you to everyone who joined from the Alteryx side of things. And please do not hesitate to reach out if you have any questions. Happy to assist.
Perfect. I think that's it then. Thanks everyone for their time. And thank you, Kathleen and Liam, for setting this up. I hope everyone found this session quite informative.
Excellent. Thanks, everyone. Take care.